Hi, good day. I'm Cecille Carado, and today I will be discussing inductive reasoning. So, what is inductive reasoning? Inductive reasoning is a form of logical thinking that involves making generalization based on a specific observation. It is a process of deriving general principle from a specific instances or example. In other words, inductive reasoning moves from the particular to the general, drawing conclusions that are likely but not necessarily certain. So to make it more understandable, I will cite an example. So May get new shoes, May grades improve. So all students should have new shoes to improve their grades. So in this example, there's an assumption that if you have a new shoes, you will have a good grade. So the next one is all cats that I have seen are white. Therefore, all cats are white. So inductive reasoning is not just used to predict numbers on a list. We can also use inductive reasoning to make conjecture about an arithmetic procedure. When you examine a list of number and predict the next number in accordance to the list, to some pattern you have observed, you are using inductive reasoning. So here's are some of the example. So problem number one, use inductive reasoning to predict the next number. 1, 5, 9, 13, and 17. So solution, each successive number is 4 larger than the preceding number. Thus, we predict that the next number in the list is 4 larger than 17, which is 21. So as you observe, if you add 4 and those numbers, you will get, or you can predict the next number. So problem number 2, in a store, every time a customer buys 2 items, they receive a $5 discount. If Mary buys 6 items, how much discount will she receive? The solution based on the observation pattern, for every 2 items, there is a $5 discount. So since Mary is buying 6 items, she will receive $5 discount for each pair of items, resulting in total discount of $15. So problem number 3, in a manufacturing plant, every time 100 units of product are produced, there are 10 defective units. If the plant produces 500 units, how many defective units can be expected? So in our solution, based on the observed pattern, for every 100 units produced, there are 10 defective units. So for 500 units, we can expect 50 defective units. Problem number 4. In a school, every time a student attends a class, they score an average of 80% on their quizzes. If a student attends 5 classes, what is their expected average score? Based on the observed pattern for each class attended, the student scores an average of 80%. So for 5 classes, the expected average score is also 80%. Problem number 5. In a bakery, every time a baker bakes 20 loaves of bread, they use 5 cups of flour. If the baker bakes 100 loaves of bread, how many cups of flour are expected to be used? So in our solution, based on the observed pattern, for every 20 loaves of bread baked, 5 cups of flour are used. So for 100 loaves of bread, the expected amount of flour used is 25 cups. Problem number 6. Every time Jane fills her car's gas tank, she records a mileage and the amount of gas purchased. After analyzing her data, she notices that her car mileage consistently increased by 30 miles for every gallon of gas used. If Jane's car has used 12 gallons of gas and has traveled 360 miles since its last filled up, how many gas does her car hold when the tank is full? So solution, based on the observed patterns, Jane's car travels 30 miles per gallon. Since it has traveled 360 miles, it has used 36,030 equals 1,230,360 is equal to 12 gallons of gas. Therefore, her car holds 12 gallons when the tank is full. Problem number 7, as population of rabbits in a forest doubles every year due to favorable conditions. If there were 100 rabbits in the forest last year, how many rabbits are expected to be in the forest this year? So based on the observed pattern, the population of rabbits doubles every year. Therefore, this year there will be 100 times or 2 equals 200,100 times 2 is equal to 200. Problem number 8. So every time you use your smartphone for a navigation, it accurately provides direction. Explain why you trust your smartphone to give your accurate direction next time you use it. So solution. Based on repeated experiences where your smartphone has provided accurate directions, you generalize that it will continue to do so in the future. Problem number 9. A plant's height increased by 5 centimeters every month. If the plant is currently 50 centimeters tall, how tall can it be expected to be in 2 years? Solution. The plant's height increased by 5 centimeters every month. Based on the observation, there is a consistent pattern of monthly height increase. Therefore, we predict that in 2 years, the plant height will have increased by 120 centimeters. So the plant can be expected to 170 centimeters tall in 2 years. So um can see all the steps for the computation here. Last problem. In a study of traffic patterns, it's observed that the number of cars passing through a particular intersection increased by 10% every year. How many cars are expected to pass through the intersection next year if 1,000 cars pass through this year? So solution, each year, the number of cars passing through the intersection increased by 10%. Based on the observation, there is a consistent pattern of annual increase in the number of cars passing through passing through the intersection. Therefore, we predict that the next year there will be 10% more cars passing through the intersection than this year. So 1,000 plus 0.10 times 1,000 is equal to 11,000,001,000 plus 0.10 times 1,000 is equal to 1,100 cars are expected to pass through the intersection next year. So to sum up, these examples demonstrate how inductive reasoning can be used to make prediction in real world or mathematical scenarios based on observed patterns or events. So that would be all. Thank you.